In this video we're going to be going over the process of making an approximately 25-ton hydraulic forging press. At the end of the video we'll squish down some steel to make some mosaic damascus as a bit of a test. This is the process. I'm starting off the project with some old I-beam to make the frame for the press. I decided to go with this as I want a fairly sturdy base, and I also want to have a decent amount of stability while maintaining a certain level of lightness. So I'm just tacking it all together here with a stick welder, arc welder, fairly thin filler rod, and I'm flipping it over here so I can weld from the bottom a bit more and then start working on the casters, because I want to have it on wheels, so you know it's not totally immobile, and also it makes a pretty fun go-kart. I'm not overly fussed about the welds on the base, but trying to get them pretty strong. And here we are sizing the drill holes through the casters up a bit so that I can bolt them onto the bottom, because I want this entire thing to be disassemblable, which adds a bit more work later but should be worth it. Getting this clamped to the base, I had to do this with all four, and then starting with a 4mm pilot hole, drilling all the way through before moving up to a 12mm drill bit. And this was seriously painful because the drill bit kept blunting, and I may have gone slightly insane, but it's finally coming to an end. So just tightening up the bolts so I can take the other clamps off and all the holes will still be aligned, and there it is, the final drill hole with the 12mm drill bit, or well, so I thought at that stage. But anyway, now that the casters are on, I took them off again so I could flip the entire frame over, because I didn't want to flip it with the casters on, so as to not put unnecessary strain on. My dad's giving me a bit of a hand here, and now I'm just bolting all the casters back onto the base so that we can drop it down, and it should be able to be wheeled around, and then I can continue to work on the press. I ended up buying pretty expensive casters because I wanted this to hold a lot of weight, which is probably overkill, but it's worth it because it holds me easily. Now that I've got the base all together, it's time to start working on the actual frame. So this is the lower part of the frame that will be the main construction of the press, which I'm drilling 6 holes into the base of, and then lining it up with the I-beam so I can drill holes into that, because I want the entire base to be bolted onto the frame again, to be able to make it deconstructible for transport, because together this thing probably weighs 500 kilos, and I can break it down to about 3 parts of like 150 kilos each, which make it a fair bit more transportable. But putting some bolts through the holes now and just making sure they're all lined up, because the next step I want to do is clean the bolts off a little bit and actually weld them to the underside of the I-beam. So that will mean that I can unscrew the bolts without having to get a spanner in there, because there's going to be another I-beam that'll be welded next to it, which will prevent me from getting in there. Welding near galvanized, so not the best, but I was wearing a respirator the whole time I was welding on the galvanized, so that probably helped, but yeah, not ideal. And more drilling with the 12mm drill bit, because I hadn't done enough of it apparently, but didn't have as many issues now. I'd got a bit more of a rhythm sorted out. And once again putting the bolts through the back and cleaning up the surface a bit to get rid of some of that zinc so it, you know, doesn't give me zinc poisoning, because that's always fun. Then cleaning a bit of the zinc off the bolts as well, the nuts rather, just on my 2x48. And going back to the frame and welding those on as well. I mean, for the back I really could have just had access to the bolts, but I decided to weld them on just to make it a bit simpler. And here I'm welding a few more bits of angle iron to the base of the frame, which is going to be where the reservoir will eventually sit. And my idea with this is that I'm just top riveting a thin section of steel behind where the press is going to go to stop scale, and also it'll be a place I can, put things. I originally tried to weld it, but that did not go well. It was like 0.2 millimeters steel or something. This janky looking setup is what I put together to square off the ends of the H-beam that I got for the main frame, because got 3 sections that one will be rolled at the top, one at the bottom, and then one in the center will go up and down, but the sides were pretty close to square and parallel, but I just wanted to get them a tiny bit cleaner. So using the grinder for that, just to square them all up. And then before I weld everything together, I wanted to get the eventual die layout set up. So got some, I think it's 1.5 centimeter thick steel here that I did some layer on and drilled some holes through, again doing a, I think, 4 millimeter pilot hole, and then sizing it up to probably a 9 millimeter pilot hole, because I wanted to use that as a pilot hole to drill through the H-beam, and I thread the holes through the H-beam, so I think they were 10 mil bolts, but I did 9 mil holes so that I could do the threading. And here I am doing the threading, which there was a grand total of 8 holes to thread, which doing that all by hand is always stressful, because breaking taps is not the funnest, but got that all sorted out, and I'm moving on to another part, which is how the cylinder is going to be attached to the frame. So I've got some, I think it's an inch, so 2.5 centimeter round bar, or it might be a bit more, but just got that cut up because it was in a longer section into 2 sections, and clean up the ends and around the corners a bit. And then I've got these chunks which had a hole pre-drilled in them, and they're just some fairly thick chunks of mild steel, which I'm squaring up the back end and getting it so it all lines up, because those are going to be welded into the H-beam, and then the cylinder will go between and the pin will go through it, and that'll mean that'll be possible to take the cylinder off those. And once again, welding that in place, still using 120 amps to get maximum penetration to the steel, because I am not a particularly good welder, so if in doubt, rely on absolute brute force and just melt everything together, right? But here you can see how I'm putting the cylinder in place to make sure that everything's lined up properly on the outside, and just tacking the 2 outside plates in place before fully welding them in place. Then repeated the process on the top, but I cut that. So this is the entire frame. Got it finagled. It was a bit difficult to get it all lined up because the concrete wasn't flat, but I've got the 3 pieces in there, and I'm welding the top and bottom, not the central piece because that needs to move, but got everything tacked, and then I go around it all, again 120 amps to get it more secure, and employed my dad again to help me lift this into place, because it was probably somewhere between 100 and 150 kilograms, and I cannot lift that on my own, certainly not hold it while putting bolts in place on my own. So got it lifted up to where it needs to be, and then got the bolts in to hold it all in place, which to my relief actually held it in place, and it didn't have any wobble, because wobble would be problematic, and also it didn't immediately just fall over. At this stage things were going pretty well, which is always good. Trying to get the part that moves up and down hammered into place, and then I'm punching some layout for holes to be drilled in some angle iron, which then goes on each side of the section that moves up and down. And basically there's some angle iron on the inside that'll be welded to the H-beam, and some angle iron that's attached to the outside of that will be bolted onto the inner angle iron, and that will hold it all in place as it moves up and down. So got the angle iron, the two different parts of angle iron lined up, and again used a drill bit while it was clamped together to get the holes lining up. And once that was done, I could bolt them all together and then take the clamp off and see if it still fitted, which in this case it did. Well, in all of the cases, which, you know, things fitting is always optimal, and it actually fit really nice and tight, which is what we like to see. Now that I had all those holes drilled for the bolts, it was time to tack weld it in place, which just did a few tacks and then some slightly longer weld beads. And with that done, I wanted to put up another bit of steel here, so this is just some random, I think it might have been stainless steel that was used as a barbecue plate or something that's pretty thin, as a kind of barrier to protect the reservoir and the hoses from any hot steel. And lifting the reservoir into place, which that is not a particularly light piece of machinery, so that was a fun challenge to get it up there, but got it into place and lined up. And then the next step was to get the hydraulic cylinder into place, which again my dad gave me a hand with because that thing weighed a lot, probably 40 kilos, and I need to get the pin through the top, which the pin through the top is quite tight. Both the pins are quite tight because I wanted it to, you know, be pretty secure. Start working on getting all the hosing rigged up to connect the cylinder to the power pack. And what I learned with hydraulics is, you know, there's the hose into the top and the hose into the bottom. If stuff pumped into top, cylinder go down. If stuff pumped into bottom, cylinder go up. So of course the cylinder needs fluid, so poured all that in. And now the grand reveal, it actually moves, which I was kind of stressed as to whether or not it would work, but it does, and I got the ram lined up with where the pin goes through the bottom plate, so we got that hammered through and into place. And then the next great test was to see whether the actual head of the ram, well, the head of the entire assembly, would move up and down. It does, so yeah. I decided to give it a quick test and squished a 2x4. I just squished it gently, but I did start to see a problem that would arise, which was the fact that because it was offset from the center of where the force was coming, it would slightly tilt. Even though I had the angle iron on the side, that wasn't really enough to stop it. So there were a few measures that I took later to fix that, but I don't think I quite realized there was a problem at this stage. So I started working on making my first set of dies for the press, which getting some more scribe lines laid out on 2 pieces of steel, which these are going to be a combination die. So on one side they'll have drawing dies, which will be fairly wide radius drawing dies, so not too aggressive, and the other side will have flat dies, which will be really long, so I can straighten things and also flatten out the divots from the drawing dies, which turned out to be very nice to work with, because constantly having to switch between drawing dies and flat dies when you're working on stuff is a lot painful, and also having the space on the flat dies to be able to put stopper blocks, kiss blocks, was also very helpful. But of course it's just a rectangular block of steel at this stage, so I actually need to make the drawing dies, which got a pretty aggressive belt and spent a fair amount of time hogging away, probably 1.5 kilos between the 2 dies of material, and then round it all over, make it pretty and smooth, and then line them all up and tack weld them into place. So of course there's the bottom plates which are bolted to the H-beam, and I'm just tack welding onto the bottom plates so I can swap them out, of course, still. and cleaning up the welds and brushing and lighting the forge, because it is time to test the press. Always fun lighting the forge like this, because, you know, normally when it ignites there's a bit of an explosion, but never had a problem with that. So got a piece of mild steel heated up all the way, and it's time to see what this press can do. So it has a tremendous amount of squishing power, but as you can kind of see at the end there, the head tilted and didn't really return, so kind of tried again a little bit and it's tilting again, and I'm starting to realize that it's quite a major problem here, but I decided to try the drawing dies just a little bit to see how they work. And the drawing dies work better because they're more central, but it is a fair bit of a problem. And here I think I am ignoring that problem and cutting another section of steel into a bunch of pieces, which I then grind flat, or rather grind the corner square. And what these are going to become is another pair of dies which will be bolted in place, but the thing that's unique about these dies is that they've got a pair of, well, the bottom and top both have slots where square bits of steel can be slid in and out. That means I can swap out a bunch of different dies while, you know, having the same base on, and also by having them square, that means if I choose I can flip them 90 degrees, so I can, for an example, have a pair of drawing dies which are also a pair of fillering dies, which is quite handy. And welding everything together, for the first pair I decided to make a pair of just plain flat dies because I wanted to do a bit more testing, and got a hot piece of steel here and just seeing what they're capable of, which these are much more efficient for actually forging material out because they're thinner than the enormous flat dies. The drawing dies, of course, are even more efficient because I've got the radius on them. Because these are also more centralized, you can utilize the corners a bit more. So forging in the tip and doing a bit of forging just to see how everything works, which these ones work fairly well, again because they're centralized and it's not force being exerted at the side. I did want to fix the previous issue of everything being skewed, so I did two things. The first is I welded the entire front of the ram to the flanges, which kind of defeats the purpose of having the pin there, but because I can unbolt the entire thing with the angle iron, I can just take that and the cylinder all out. Now that the press is effectively done, here are some shots of me doing a little bit of a test and forging out some mosaic damascus. So enjoy those shots, and I hope you enjoy this video, and we will catch you in the next one.